Hello, grade nines. Here we are making a nice little table. Yes, for
It's
car.
a measurement of the heart rate beats per minute.
It's beat per minute. Yep. So this will be time symbol T. I'm going to use minutes because minutes are nice in this case. You could use seconds as well, but minutes my brain can handle more. There's gonna be 0, 1, 2, then 2.5, 3. Now I'm going to select these. I'm going to drag down because the computer will guess the pattern that I want. Oh, that was so quick and easy. That was awesome. Heart rate. What's a good symbol for heart rate? No, that's the units. HR for heart rate? Sure. Slash beats per minute. Okay, now looking at my photograph of Picard's data. Thank you, Picard, for sharing. Or maybe I shouldn't say that, but it's too late. Heart rate is 72. 130, 138, 127, 108, 93, 79, 72, 77, 72, 69, 67, and 82. Table, first table. I'm going to center this. Also, these uneven data points are really horrible. Everything should have one decimal place. So we're going to do that. That's better. Give this a title. The title will be heart rate versus time during and after exercise. Something like that. That's reasonable. So your table should be done, or the first bit of your table should be done. You're going to find out you need to do a second bit of your table. Then you go to Logger Pro. I just copy these numbers and I paste them into Logger Pro. Also, I'm recording this right now. This will be posted on YouTube later, so you can see this. Then I'm going to, my X is time. I'm going to double click on X. This is time, short name T as a symbol, and my units are min for minutes. It goes there, and because Logger Pro is awesome, it's down there too. My Y is heart rate. And the suggested symbol was HR, and the units are beats per minute, BPM. Yes. Now we have, oh, I gotta save this. This is untitled. I'm gonna save this as a real file on my computer. I'm gonna go to my folder of human body, circulatory system. No, I know where. That's under formative. SS. Formative. Heart rate lab. Student results. And this will be heart rate student work 2024. Now, this is a wacky pattern, and we may not get, I don't think we're going to get a nice mathy function. So in this case, we're going to do the horrible, I really hate it, but just to make, oh, actually, that's not bad. That's not bad. And I will, that's not bad. And we're going to auto scale from 0. That's not bad. I used the Evo quadratic, never used the quadratic. Or the quintic. I think I used the quintic. Never used the quintic except for something fake like this. Okay. Then I would take a screenshot of this graph. Oh, I gotta put a title. How do I put a title on Logger Pro graph? Just double click the graph and click on graph options, and there's room here for a title. So I'm gonna say heart rate versus time during and after exercise. Then I would take a screenshot of this and I would go to good old Toddle right here and I would paste it in. It says 2 graphs. No, it says 2 graphs. You know what I need to do? I need to read the instructions so I know what else I need to do. So, that's my first graph. The instructions say, no, I need to have a heart rate, but also a percent increase in heart rate. I need to go back to my table and I need to have a percent increase. Oh my goodness. I would pause what I'm doing now and I would look up Mr. Fleming. That might be useful to me. Percent increase in heart rate. Now this part, how can I get a percent increase? It's how much the heart rate increased. How can I calculate the percent something increased? Any ideas? Because this is some thinking that we have to do now. Yeah? Divide by the original number. So that it'd be the increase divided by the original number. So the first one, that's going to be 0. That times 100. So it went up to 130. So how could I find the percent increase? He said there's the difference. How do I do the difference, Arshan? So should I do it on a calculator or should I let the computer do it for me? Do it at the computer for me. So I'm going to say equals. How was it listening to me? Like, how did it know what I wanted? So is this kind of proof that computers listen to you? Possibly. Or it could be a coincidence. That's pretty wacky. So it's going to be this minus that divided by B2. But there's a problem here, actually, because it's going to be wrong. Oh, times 100? There's another problem, too, though. Because when you go fill down, pay super close attention to this. Let's raise these. What happened is, now it has B3 and B4 and B5. This is super important. You need to look up here because you do not know this special move. I always want it to be 72. So it's filling down and changing the purple number. So it's not as good as it could be. I could be lazy in writing 72, but then the 72 could change. So let me show you a special move that you don't know. I'm guessing you don't know. Who knows the $sign, the locking function? Does anybody know this function? No. It was called an absolute cell reference. By putting in these $signs, when I go fill down, I'll show you in a second, it stayed the $signs for any cell that I'm in. So that locks it. So when you go fill down, it stays at 72. If it wasn't 72, if it was like 80, then it's always going to be whatever that cell is. If it was 69, 68, it'd be that number. But I'm going to put it back to 72. Remember, this is all being recorded. It will be on YouTube for you afterwards. So the function that you want to do, Google guessed what I want to do, but it wasn't exactly what we want. We have like 1 minute left. It's 10:14. 1 minute left. So the function that you want to do is the difference, which is this number minus this number, divided by that number times 100. But you must put in these dollar signs, and the dollar signs make it what's called an absolute cell reference. So when you go fill down, it locks it to 72, or at least the cell B2, whatever number's there. So then you can make a second graph with these numbers, with the percent increase. So you can see there's a huge percent increase. There's actually a decrease for some of this as the students' heart rate went lower than the resting heart rate. That's kind of interesting. So you have to make two graphs. One graph of time versus heart rate, and one graph, I need to wrap this as well, and we're like out of time. Percent increase in heart rate. Where's wrap? Here's wrap. Wrap, that's better. Okay. We're at 10:16, so we're over time to enjoy your break. I'll stop the recording. Later, this will be posted to YouTube, and I'll put in the class chat the video so you can watch this. Okay, if we spoke too fast for you.